After careful observation of the overview screen, now we are ready to do some lead testing. Let's check out the impedance and continuity tests of the atrial, right ventricular, and left ventricular lead, which are running and showing up as normal and stable within time. And then the RV coil continuity will be shown with a higher impedance than we are used to in other companies, which takes a little while longer, shown here as normal, also at 485. Let's do some sensitivity tests. So we start in DDI 30 mode, which is the default mode, which always works. We here see the atrial sensed events and the ventricular sensed events. Normally in a CRTD patient, the patient has preserved atrioventricular conduction. Here the ventricular and atrial sensing are correct. So we will proceed to the pacing threshold tests. It shows you to start with the RV lead. Okay, let's start with RV DOO pacing at 2.5 volts. We see here that a capture has been lost after 1 volt. So 1 volt is the threshold. We click on save, so it's saved into the memory of the device. And then for the LV lead, it is a bit more complicated as there are more options. Let's start with as programmed, so DOO 3.5 volts, LV tip to RV coil. We run the test and we see on the ECG at the top that pacing threshold has been lost at 1 volt. So the pacing threshold is 1.25 volts. It is the exact same threshold as we found last year, so the pacing threshold has been stable. If we want, we can also save at what threshold there has been a phrenic nerve stimulation, so PNS. When we click on LV pacing polarity, we can easily see which LV pacing vectors are possible. We can then change to another vector. For example, LV tip to ring, otherwise known as LV bipolar. We will now perform a pacing threshold test using this classic combination. We can already appreciate when looking at the ECG2 at the top that there has been a loss of capture at high pacing output, already at 2.75. Therefore, the pacing threshold is at 3. We did not observe any phrenic nerve stimulation, but the output is clearly quite high for this combination. When we click on LV vectors, and then we can select all possible pacing vectors and test them one by one. So here is the first, which is the same as we tested before, which is the LV bipolar. Let's confirm it's a high pacing capture for this lead combination, and indeed we can see that it is still very high at 275 this time. So let's save that into device. And then it proposes you to perform the next tests. So here it will automatically switch LV pacing vectors. Now LV tip to RV ring. Let's see how the pacing threshold holds out for this vector. Already looking better than the bipolar combination. And indeed, the pacing threshold is here now tested at 1.25 volts. Didn't see any phrenic nerve stimulation in the patient. Next combination is the LV tip to RV coil. This is the pre-programmed combination, so it's nice to see and clarify whether this is the best pacing option. No phrenic nerve stimulation, and we can also see that pacing threshold is very acceptable at 1 volt. Save that into the memory of the device. Then we go to LV tip to CAN. We can now appreciate that LV tip to CAN has been capturing all the way up until here, 0.75 volts. So we have a threshold at 1 volt. Let's save that into the memory of the device. No phrenic. And then we'll go to the next, which is LV ring to RV coil. I expect this threshold to be higher because every time I tested the ring, it has had a high pacing threshold, and that's also the case here. I think we are not capturing at all, so I would just select the highest value, but obviously it would be better to redo the test with a higher amplitude to see if you would get a capture at a high amplitude, but I would not select this vector anyway. So let's test the last LV pacing vector, which is the LV ring to CAN. I don't have my hopes up for this one because LV ring is clearly not producing very nice pacing thresholds. So here we also see that there's no capture during the test. So we'll just select the highest one, 3.5, and then it will show me later in the table a nice overview of all the possible pacing vectors and the tests I did, and it's quite clear to appreciate that the LV tip combinations are acceptable and the LV tip to RV coil is a very nice final result. So there is still one lead to test, the atrial lead. If we now run the test in DAO mode at 90 beats per minute, we can see that on the atrial EGM there are extra events occurring all the way at the end. So pacing capture for the atrial lead is very acceptable at half a volt. Save that into the memory of the device. When you click on Sonar CRT optimization, it allows you to perform a manual Sonar CRT optimization test, meaning that it will automatically run a set of AV and VV intervals, test the sonar amplitude, and show you which one is the most optimal one.